All right, so I have some brief directions for how to do just any of these, and then I have a few more examples, three more examples in total. So first, the directions. To find delta given a function, a limit, a number we're approaching, and some epsilon greater than 0. Remember, could be a number. We've done a couple of those examples, or it could just be arbitrary epsilon. First, solve the absolute value of f of x minus L less than epsilon to find an interval. That's the process we've been going through. Sometimes it works out really nice, sometimes it doesn't. 2, minimize the distance to C. And these are parentheses, and that distance is going to be equal to our delta. So it's really not terrible. Let's take a look at this example that I have. Show that the limit as x Show that the limit as x approaches 2 of x cubed is equal to 8. So we're going to start with some random generic epsilon greater than 0. And we're going to start by taking our function minus the limit and setting it less than epsilon. So f of x, the x cubed, minus the 8 is less than epsilon. We're nowhere near having absolute value of x minus 2, so I'm going to switch out of the absolute value notation. So I'm going to sandwich my inside in between negative epsilon and positive epsilon. Once I do that, I add 8 to all three parts. And then I take the cube root all the way across to get the x all by itself. What this has done is it's very much like that last one, except that we have epsilon running around instead of just some nice numbers. We have an interval here. As long as x is in between these two things, admittedly kind of ugly things, we know that it works. But just like on that last one, we now have to center it at C. So what we have is this. We have our number line here, and it's centered at 2. Right? We're trying to find a delta that will work. So what we need to know is which one is smaller, the distance from 2 to this left endpoint of our interval, or 2 to that right endpoint. For the left one, that would be 2 minus the left endpoint. You subtract, you do the bigger number minus the smaller to get that distance. So 2 minus that left endpoint. For the right one, you do the right endpoint minus 2. And then we don't know what epsilon is. Who knows which one of these is bigger? We don't. So we're just going to, it's almost cheating. We're just going to say, use the minimum of those two distances. So we have them both, and delta is just whichever one is smaller. And there it is. That's not too bad. Let's do another. I've got 2 more examples. Okay, for our next example, we want to find delta for the limit as x approaches 24 of 120 over x is equal to 5. And this time we have a number for epsilon, if epsilon is equal to 1. So we're going to start at the same place. We're going to start with the absolute value of my function minus my limit, and we're going to set it less than epsilon, which in this case is 1. So if you need to see it there, that's my epsilon, right? The 1. So again, I'm going to get rid of the absolute value notation. The absolute value being less than 1 means that the stuff on the inside is sandwiched in between -1 and +1. I add 5 to both sides, which gives me 4 is less than 120 over x is less than 6. And so now we have a little dilemma. X is in the denominator. Sure, it'd be nice if we could just flip it over. Well, we can't. But watch what happens, though, if we flip the middle. So if we flip the middle to make x over 120, we're going to take reciprocals of all 3 parts. Basically, we're doing 1 over all 3 parts. It's legal, but notice what happens. 1/4 is bigger than 1/6. Right? 4 was smaller than 6, but if you flip it, 1/4 is bigger. So when you flip it, the signs have to switch directions. If you do that, it works. It's completely legal. I multiply everything by 120, which gives me 30 is greater than x is greater than 20. So my interval is from 30 to 20, or sorry, I guess I should say that the right way, is from 20 to 30, but we're interested in being at 24. So again, we need to do some subtraction to find our delta. So 30 minus 24 for that right-hand side gives us 6. 24 minus 20 for the left-hand side gives us 4. 4 is smaller, so there's our delta. Delta is the 4. All right, one more example, then I think we're actually done. All right, our last example. Find delta if epsilon is greater than 0. So again, we have a generic arbitrary epsilon of unknown size. Here's our function that we want, or here's the limit that we want to try and do it for. The limit as x approaches the square root of 3, that's fun, of 1 over x squared, and that is equal to 1/3. That's what we want to find delta for. So we start the same place. Absolute value of our function, 1 over x squared, minus the limit, 1/3, has to be less than epsilon. In this case, we don't have a number, right? We're just working with the generic epsilon. So I get rid of the absolute values. The stuff on the inside is sandwiched in between negative epsilon and positive epsilon. I add 1/3 across the board. So we have negative epsilon plus 1/3 is less than 1 over x squared is less than epsilon plus 1/3. And now I'm ready to flip it, just like on that last example. Make sure you don't flip too soon. You have to just have that one thing in the middle with x in it. So we flip. Now the reciprocals for these messes on either end are just 1 over the mess. Okay, so yeah. You get 1 over negative epsilon plus 1/3 is less than x squared is less than 1 over, oops, sorry, guess what I forgot to do? I forgot to turn my signs around. Oh boy, that's gonna make a mess. Let me fix that. Oh dear. All right, so we'll come back to this down here then too. Ah, darn it. Anyway, so I flip the signs because we need to do that, and then I take a square root. So we have the square root of that mess is greater than x is greater than the square root of that other mess. Oh boy, that's fun. Yeah. All right, so now here's the kicker. Well, there are a few kickers. We'll get to this minimum here in just a second. The first kicker is this. Your book is probably going to try and clean this mess up just a little bit. Okay, so please be very, very careful. And yeah, just be careful because it's a mess. It's a disaster. I suspect it would combine some fractions and stuff, and you might, I don't care that much. You might have a right answer. It just might not match what the book has. Anyway, so we need the minimum. This is the bigger one. So this will be the second part of it. That'll be the square root of 3 minus the square root of 1 over negative epsilon plus 1/3. Right, because this is the right endpoint. I did that wrong. That's backwards. Oh, you guys are all like, come on, Mr. Sandlin, give us a good video. I'm trying, I promise. Let's try that again. This mess, 1 over negative epsilon plus 1/3, the square root of that, minus the square root of 3. And then the other one would be the square root of 3 minus that guy, square root of 1 over epsilon plus 1/3. There we go. That's better. Isn't that exciting? So, yeah, big fun. Hopefully you followed all of that. If not, I'm sure you'll be asking me questions when you show up for class. So have a wonderful day, and thanks for coming. Bye.